So in this video, I'm going to go through the 3.4 to 3.5 review. The first question wants me to find the remainder when it's divided by an expression x minus 5. I am going to use synthetic division here. You could also use long division. So when I want to use synthetic division, I want to set this equal to 0 and then add the 5 over. So I am going to use 5 for synthetic division. 5 goes on the outside. Then I want to write down my coefficients. I have 1, -5, -7, and 25. My first one always goes down. 1 times 5 is 5. I add down. -5 plus 5 is 0. 5 times 0 is 5. 5 times 0 is 0. -7 plus 0 is -7. -7 times 5 is -35. 25 minus 35 gives me -10 for my remainder. Next one wants to see if this is a factor of my polynomial, and if it is, factor completely. Again, I'm going to use synthetic division because I like it better. I'll show you long division later in this. So I'm going to set this equal to 0. And then I subtract 3 on both sides. I get x equals -3. So then I'm going to go ahead and use synthetic division. The -3 goes on the outside. On this one, I have my x to the 5th, 4th, and 3rd. I'm missing my squared x and constant. So I need to write zeros for all 3 of those. So I'm going to have 6, -15, -9, 0 for the x squared, 0 for the x, 0 for my constant. First number always goes down. 6 times -3 gives me -18. -15 minus 18 is -33. Times -3 gives me +99. Then I add down. That's going to give me +90. Times -3 is -270. Add down. -270 times 3 is +810. 810. Then I want to multiply by -3. This gets me -2,430. I add down. -2,430. So that is not 0. This is not a factor. Next one, again, same thing, deciding if it's a factor. So I'm going to start off by taking the divisor and setting it equal to 0. This gets me x equals 4. This one, I'm not missing any terms, so I can go ahead and write it. I have 2, 5, -37, -60. Bring my 2 down. 4 times 2 is 8. 5 plus 8 is 13. 4 times 13 is 52. Minus -37 plus 52 is +15. Times 4 is 60. This gets me 0. This is a factor. So now I need to keep factoring. I'm going to turn this back into a polynomial. I have 2x squared plus 13x plus 15. I am going to use the AC method to factor here. So my a value is 2, my b value is 13, and my c value is 15. I'm going to take a times c, which is 2 times 15. This gives me 30. I'm looking for 2 numbers that multiply to 30 that add up to 13. So if I wanted to check on my calculator, I can do 30 divided by x, and if I go to my table of values, I can scroll. I have 1 and 30, 2 and 15, 3 and 10 is what I'm going to use. So I'm going to split my middle up into 3 plus 10. I have 2x squared, and then instead of 13, I'm going to do plus 3x plus 10x, and then plus my 15. I'm going to go ahead and factor by grouping. So on my first group, all they have in common is an x. I pull that out. I have x times 2x plus 3. On my second group, I can pull out a 5. That is going to give me a 2x plus 3. Then I want to put my outside pieces together because I'm undoing the distribution. So I have x plus 5, and then the repeated part gets written once, so 2x plus 3. And then remember, I factored out this x minus 4 at the beginning, so I need to add that back in. There we go. Numbers 4 and 5 want me to use long division. So for this one, I want to set it up. X plus 2 goes on the outside. This one, all of my exponents are there, so I go ahead and write it in. I have 3x cubed minus x squared minus 7x plus 6. I want to turn x into 3x cubed. I need to multiply by 3x squared to do that. So I'll take 3x squared times x plus 2. That is going to give me 3x cubed. So I distribute that. 3x squared times 2 is 6x squared. Then I want to change all of my signs. And I add down. 3x cubed minus 3x cubed is 0. Negative x squared minus 6x squared is negative 7x squared. I bring down my remaining terms. Now I want to turn x into negative 7x squared. I'm going to multiply it by negative 7x. So negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x. Change my signs. That is going to give me the x squareds cancel out. Negative 7x plus 14x gives me 7x. And then the 6 goes down. I want to turn x into 7x. I multiply by 7. So 7 times x plus 2. It's going to give me 7x. 7 times 2 is 14. Then I change my signs. 7x minus 7x cancels out. 6 minus 14 is negative 8. So this part is part of my answer. I have 3x squared minus 7x plus 7. And then this is a remainder. I have, oops, that should be minus 8. Minus 8 over what I was dividing by, which was x plus 2. So same thing for my next one. I am dividing by 2x minus 2. I'm going into 2x cubed plus 10x minus 6x minus 3. There's nothing that's missing. Oh, this is a squared. All of my exponent terms are there. So then I want to get started. I want to turn 2x into 2x cubed. I have to multiply by x squared to do that. So I'm going to multiply that whole thing by x squared. X squared times 2x is going to give me 2x cubed. X squared times negative 2 gives me negative 2x squared. Add down. Oh, change my signs. And then I want to add down. 2x cubed is, or 2x cubed minus 2x cubed is 0. 10 plus 2 is 12x squared. Everything else goes down. Then I want to turn 2x into 12x squared, so I'm going to multiply by 6x. So 6x times 2x is 12x squared. 6x times negative 2 is negative 12x. Then I'm going to go ahead and change my signs. 12x squared minus 12x squared is 0. Negative 6 plus 12 is positive 6x. And then that minus 3 goes down. I want to turn 2x into 6x. I need to multiply by 3. So that's going to give me 6x. 3 times negative 2 is negative 6. Then I want to change my signs. 6x minus 6x cancels out. Negative 3 plus 6 is 3. And I'm going to go ahead and write this out. The top part is the first part of my answer. Then I have plus 3 over what I was dividing by, which is 2x minus 2. My last two want me to use synthetic division to divide my polynomials, so I'm going to take this and set it equal to 0. That is going to give me x equals 3 for the number I'm dividing by. This one isn't missing any terms, so I just write their coefficients. I have 1, -8, 17, -10. I'm going to draw a line so I don't get confused with that. Then I'm going to go ahead, I bring down the 1, 3 times 1 is 3, -8 plus 3 is 5, 3 times 5 is 15, 17 plus 15 is 32, times 3 is 96, -10 plus 96 is 86. I want to put back in my letters. I'm going to have x squared plus 5x plus 32 plus 86 over x minus 3. It always goes over what I was originally divided by. Same thing over here. I'm going to set this equal to 0. I subtract 5 on both sides. I get x equals -5. So then plugging in to do my synthetic division, -5 goes on the outside. All of my terms are counted for, so I'm going to write all their coefficients. I have 2, 7, -11, 21, and 5. Bring down the 2. 2 times -5 is -10. 7 minus 10 is -3. -5 times -3 is 15. -11 plus 15 is 4. 4 times -5 is -20. 21 minus 20 is 1. 1 times -5 is -5. I have 0. That means I don't have a remainder at the end. So then I want to plug back in my x's. I have 2x cubed minus 3x squared plus 4x plus 1. Okay. On the back, it wants me to find all the zeros of the function and sketch a graph. So it wants me to describe the multiplicity and state whether the 0 is a turning point or whether it crosses through the axis. All of these are in factor form, so I just take each and set them equal to 0. I have x squared equals 0. I have x plus 3 cubed equals 0. And x minus 2 equals 0. The first one, if I take the square root, I just get x equals 0. This one, the cube root of both sides, is going to give me x plus 3 equals 0. I subtract 3. I get x equals -3. And the last one I just add 2, so I get x equals 2. So I'm going to go ahead and put all of those dots on my graph. I have 1 at 0, -3, and 2. My 0 at 3, because it has an odd number, it crosses through the x-axis. It only bounces for evens. The 0 at 0 bounces, or is a turning point. Oh, I should have said turns, not turning. At the x-axis, and the 0 at 2, there's no exponent here, which is an implied 1, means it crosses. And then all of my x values are positive, so that means it should be going up. I'm going to graph this on my calculator. I have x squared times x plus 3 cubed times x minus 2. And then I'm going to graph it. Ooh, I should fix my zoom in a second. To fix my zoom, if yours looks weird, you go zoom 6 and then it turns it back to a normal graph. So mine looks something like this, which matches up with what I said. Okay, numbers 9 and 10 want me to determine all the real and complex zeros of each polynomial function. So I want to factor. I'm going to factor by grouping from my first one. This first group has an x squared in common. I'm also going to set it equal to 0. So I can pull out that x squared, then I have x minus 7. In my second group, I can pull out a 4. So then I have x minus 7 there. Then I'm going to have 0 equals, in parentheses, x squared plus 4 times x minus 7. I'm going to take each of my things in parentheses and set those individually equal to 0 by the 0 product property. The first one, I want to subtract 4. I get x squared equals -4. I want to take my square root. So because I'm taking the square root, I'm going to get a plus and minus answer. And then because my number was negative, it should have an I. and the square root of 4 is 2. So that's that part. Over here, I add 7 to both sides. I get x equals 7. Second one, I want to factor by grouping again. In my first group, I can take out an x squared. So I have 0 equals x squared times x minus 4. My second group, I want to take out a negative 2, which leaves me with x minus 4. If I put my terms together, I get x squared minus 2 times x minus 4. Individually, I'm going to take those and set them equal to 0. So on the first one, I add 2 to both sides. I have x squared equals 2. I want to take my square root. It's going to get me x equals plus or minus the square root of 2. On the second one, I add 4. I get x equals 4. This one wants me to write a cubic function whose graph passes through the given points. It says the graph has a vertical compression by a factor of 1/2, so that means I'm going to multiply by 1/2 out front. And then I want to give all of my zeros. Those are at x minus 2, so that's going to be x plus 2. Then there's one at 1, that's going to be x minus 1. And then there's one at 4, which is going to be x minus 4. So I was looking at, let me hide these. I was looking here, here, and here to get those values. And I do opposite their sign in the parentheses. Number 12 wants me to find the values of x that are the solution to the inequalities. And use a graph to solve. So I'm going to factor this. I can pull out an x from all of those. That leaves me with x squared plus 2x minus 3. I'm looking for what multiplies to negative 3 and adds to 2. That is positive 3 and negative 1. Then I'm going to take all of my factors and set those equal to 0 to find my zeros. I have x equals 0 already solved. And I have x equals negative 3, at 1, x equals 1. So I'm going to put points at those 3 values. Then I want to go ahead and graph this. I know it should look, because it is positive and odd, it should look something like that. I'm going to go ahead and sketch that. Look something like that. I want values that are greater than 0. That means positive y values. So here and here. So I have the y values between negative 3 and 0. And then starting at 1, forever to the right. So that means to infinity.